Hello my scholars, welcome to my school YouTube channel. My name is Emmanuel and today we'll be tackling JAMB past question in chemistry for year 2001. Please don't go anywhere, stick around and we'll be right back. You're welcome back to my school YouTube channel. Like I said earlier on, today we'll be looking at JAMB past questions in chemistry for year 2001. Today we'll be tackling question 1 to 25. Now let's go to question number 1. 25 cm cube of a gas X contains Z molecules at 15 degrees Celsius and 75 millimeter mercury. How many molecules will 25 cm cube of another gas Y contain at the same temperature and pressure? This is just Avogadro's law, okay? And what does it say? It says that equal volume of different gases contain the same number of molecules, okay, at standard temperature and pressure, provided at temperature and pressure. And if you look at this, we're told that they contain the same at the same temperature and pressure. So that means at STP, standard temperature and pressure. So for that, it means that the number of molecules of gas X and the number of molecules of gas Y definitely will be the same. If you look at this question now, since the volumes are actually the same, okay, that's what Avogadro law says. Since volumes are the same, for gas X is 25 cm cube, for gas Y is 25 cm cube, then at the same temperature and pressure, then the number of molecules for X will be the same for gas Y. So 25 cm cube of gas X contains Z molecules. So which means that gas Y will also contain Z molecules. So if you look at option A, says 2Y, option B says 2Z, option C says Z, and D says Y. So because both of them will have the same number of molecules, since they have equal volumes at standard temperature and pressure, the same constant, then number of molecules will also be the same thing. So which means option C is the correct answer. Now question number 2. What mass of water is produced when 8 grams of hydrogen react with excess oxygen? Okay, what mass of water is produced? So first we need to write a balanced chemical reaction, okay, to show the reaction between oxygen and hydrogen to produce water. So let's move over to the board now. We have hydrogen gas reacting with oxygen to produce water. The equation is balanced already because we have 2 here, 2 times 2, that's 4 moles of hydrogen, 2 times 2, that's 4. We have 2 for oxygen here, these 2 also covers for this. So now, if you look at the ratio, this is ratio 2 is to 1, in terms of number of moles is to 2. But our area of concentration is actually between hydrogen and water, because we are asked to find what mass of water is produced when 8 grams of hydrogen produces this. Okay, so we might just need this, will just be silent. So now it's ratio 2 is to 2. So if it means that if we have, let's calculate the mass of this. Hydrogen is 1, okay, times 2, okay, that's the mass. We want to calculate the mass of hydrogen. If hydrogen is 1, it's given already, times this 2, then multiplied by 2 here, okay, because we have 2 moles there. Then let's do for this. This is also 2 times hydrogen is 1, then times 2, okay. Then we have plus oxygen is what? 16. So we can have that. So this will be 2 times 1 times, that's 4 grams. So it means 4 grams actually is going to produce. This is 1 times 2, that's 2, plus this, that's 18. 18 times 2, that gives us 36 grams, okay? So 4 grams will produce 36 grams based on this equation that we have. But the question says that what mass of water is produced when 8 grams of hydrogen, what mass of water, this is actually for water, okay? So what mass of water, we don't know that, will be produced when 8 grams of hydrogen. So we have here 8 grams of hydrogen is reacted with oxygen. So we can do the relationship. This multiplies this, right? So this can be, let's say M. We can use M here of water to show that is what we want to find. So that's 4 times m will be 4m, okay, equal to 8 times 36. So by the time we divide both sides by 4, we have m. Of course, this cancels out this. 4 goes here, 1, 4 goes here. That will be 9 times. Okay, so we have 8 times 9. That should give us 72. So 72 grams. So in other words, 8 grams of hydrogen is going to what? Produce 72 grams of water. Let's move over to the board so we can look at our options. Okay, so for what we just solved now, we have mass to be 72 grams. So from our options here, not 36, not 8, option C, 72, and not 60. So the correct answer here is option C, 72 grams. Now question number 3. A particle that contains 9 protons, 10 neutrons, and 10 electrons is a what? We have negative ion, we have positive ion, we have neutral atom of non-metal, we have neutral atom of a metal. What's the correct answer? Let's go back to the question. The particle contains 9 protons, 10 neutrons, and 10 electrons. Don't forget, if it were a neutral atom, okay, number of protons was supposed to be equal to number of electrons. Okay, we discussed this elaborately when we talked about atomic structure, okay, and bonding. There was a video lesson we did on that, so you can just subscribe to that and go through so you can have a proper in-depth of atomic structure and bonding. Okay, so a neutral atom, number of protons were actually supposed to be equal to number of electrons, but in this case now number of protons is not equal to number of electrons. 9 proton, 10 electrons. So what happens? So what happens is that the number of protons here has reduced here, while this one is more. So which means that this number of electrons has increased by 1 from this. Okay, so what it means is that that particle actually has received 1 electron. Okay, that's why we have 10 electrons here. Okay, because it's the electrons usually that are lost. Okay, so the number of protons remain 9. So number of electrons is 10 because that particle has actually accepted, okay, 1 electron from maybe from a neighboring party. So what we are looking at now is if we have 9 protons here and then we have 10 neutrons here, so it means that which one is more? Number of electrons that is more is 10. So which means that it is actually a metal, because usually when a substance or an atom gives out, okay, an electron, what happens? It becomes positively charged. Okay, but once it receives, it accepts an electron, it becomes what? Negatively charged. So in this case now, this option says neutral atom of a metal. This cannot be the answer because number of protons and number of electrons are not the same. So this is not correct. Neutral atom of non-metal. If it were a neutral atom of a non-metal, definitely number of protons should be equal to number of electrons still, because it's a neutral atom. Then option B says positive ion. If it had been positive ion, if we have the number of protons, okay, more than number of electrons. If the number of protons were more than number of electrons, then that means that protons are actually more than number of electrons. So it would have been a positive ion. Okay. But in this case now we have number of protons lesser than number of electrons. So which means electron has been gained. Electron has gained. 1 electron has been gained, okay, or has been received or accepted. So in that case now it means that number of electrons actually is more than what? Number of protons. So based on that, the number of electrons being more than number of protons shows that an electron has been added. So once an electron has added, it means that that particle is actually going to be a negative ion, not a positive ion. Okay, so the correct answer here is option A, negative ion. Question 4. Cancerous growths are cured by exposure to, I think this is so easy. If you have gone through our video lesson under radioactivity, we talked about this one elaborately. So you can just click on the link in the description below that will take you to my school website where you'll be able to subscribe, and then you have access to the video lessons. Okay, if you have gone through that, this is just a away from here. We have cancerous growths are cured by exposure to what? We have gamma rays, we have beta rays, we have alpha rays, we have infrared rays. Already we know that these are the most common or popular among all the different kind of rays that we have. Usually, alpha particles, they have the highest ionizing power but the least penetrating power. Okay, followed by beta rays, then followed by the gamma rays. Now, this question is saying that cancerous growths are cured. Whatever kind of ray that will be able to cure, cancer should be able to penetrate through human skin. Okay, and among all of this one, if you look at this, alpha rays can be stopped by a piece of paper. It can't penetrate even a piece of paper because its penetration power is low. Followed by this can pass through a piece of paper but cannot pass through human body. So talking about cancerous growth, that means we need a ray that can be able to go through human skin and then destroy the DNA and the tissue that is present there. So the only way that can do that, or that has the power to do that, actually is gamma ray, because gamma ray has the highest penetrating power, is the highest among all the rays that exist. So it can go through human skin, penetrate through and destroy the DNA and the tissue that is there. So for that, the cancerous growth can be cured by exposure maybe of the human body to the gamma ray. So option A is the correct answer. Question number 5. An oxide XO2 has a vapor density of 32. What is the atomic mass of X? We have also treated this in the video lessons. Okay, so an oxide of XO2 has a vapor density of 32. What is the atomic mass of X? So first, we need to know the relationship between atomic mass and vapor density. Atomic mass, relative atomic mass. We are saying the same thing. So the vapor density is actually times 2 that makes what? Relative atomic. In other words, atomic mass is equal to 2 times vapor what? Density. 2 times vapor density. So let's move over to the board and let's see what we have. So what we mean is that atomic mass is actually equal to 2 times vapor density. So atomic mass, we already given the molecular formula of that to be XO2. Okay, so we have X02, that's XO2, okay, is equal to 2 times vapor density. We know what O is, oxygen is, but we don't know X because we want to calculate the atomic mass of 2. So in other words now, we can say that XO2 is equal to 2 times. So I think it's better we use, instead of atomic mass here, we can use relative molecular mass. Relative molecular mass is better used here because that's the relationship between it and vapor density. Relative molecular mass. Okay, so that shows the relationship between it and what vapor density is. So we know that X plus oxygen is 16. Okay, that's the mass of 16, atomic mass of 16, but we have 2 of that. So multiply by 2. So that will be equal to 2 multiplied by vapor density. We're given already from the question that is 32. So we substitute that here. So we have X plus 16 times 2, that is 32, equal to 2 times 32, that gives us 64. So that X will be equal to 64. When you move this to the other side, it becomes negative 32. So X is actually equal to 32. So which means that the atomic mass of X is 32. But the relative molecular mass, if you want to calculate that, we can now say 32 here plus the 32 of this, that will be 64. So relative molecular mass is actually equals to 2 times vapor density of that particular thing. So the atomic mass of X now is 32. Let's move over to the screen so we can look at the options we have here. Okay, option A is 32, which is what we have as answer. Option B is 20, no C. So out of this option, the correct answer is option A, which is 32. Question number 6. Millikan's contributions to the development of atomic theory is the determination of what? In fact, all of these topics we have looked at. Now these questions now, we've had their video lessons before, okay? So Millikan's contributions to the development of atomic theory is the determination of what? There's no point even beating around the bush. Just move over to option A and then just choose it and go. Because option B, positive rays, were actually, propounded by Goldstein, okay? Charge to mass ratio was by J.J. Thomson. Also cathode rays by J.J. Thomson. The experiment, cathode ray experiment, was done, carried out by J.J. Thomson. So we are talking about Millikan. It was in year 1910 that he actually propounded that. So the answer is charge on the electron. He was able to discover, the charge on electron, okay, the value that we actually have. So the correct answer is option A. Question 7. 4 elements W, X, Y, and Z have atomic number 2, 6, 16, and 20 respectively. So which means 2 is to W, 6 is to X, 16 to Y, and 20 to Z. Which of these elements is a metal? Which of these elements is a metal? I know you are just guessing now, and your guess might be right actually. If you know the atomic number of your first 20 elements, you can tell which one is a metal and which one is not a metal. 2, this is element helium. Helium is in group O, is not. 6, this is for carbon, it's not a metal. Of course, this is a noble gas. This is a group 4 element. Then this is 16, that should be sulfur, okay? And then this is 20, this should be calcium. Of course, it is what? 20. But in order not to just guess, in case you want to be sure, if you write the electronic configuration of each of them, this will be 1s2. So which means that the S is completely filled. So that is actually for what? For the noble gases. Then let's move to the screen, to the board. With atomic number 2, that will be 1s2. The one with 6 will be 1s2, 2s2, 2p2. 2 plus 2, 4 plus 2, that's 6, okay? The next one is 16. 16 should be 1s2, 2s2, 2p6. Then we have 3s2, okay? 3p, let's see, 2 plus 2, that's 4 plus this, that's 10, plus 2, that's 12. 12 from 16, that's 4. Okay, so we have 4 here. And then the last one is 20. 20 is 1s2, 2s2, 2p6, 3s2, 3p6. Let's add up 2, 2, 2, that's 10. That's 18. So we have 4s now. That's the next orbital. That's 4s2. Okay, so if you add up that, this should give you 2 plus 2 plus this, that's 10. That's 10, 20. So this gives us 3. Now, if you look at this now, the one that actually has, we know already that it is the noble gases, okay, that are in group O, okay, because the electron in the atomic shell is completely filled. So, but the element that actually has this, so it means that it belongs to group 2 for this because of this 4s orbital. So, group 2 elements from the periodic table, we know that they are called the alkaline earth metals, and which is what, of course, we have already said that calcium actually has this. This is what? Sulfur, and this is what? This is carbon, and this one is what? Helium. It belongs to group O element. So the metal among them is just this, among all of this one. So which is what? 20, the one with 20. So let's look at that. Which element is that? From the option, that is Z. Okay, so that's Z. Okay, so that's Z. Let's move on to the board now. Let's see what we have. So the question says, which of these elements is a metal? So we already saw that that is the one with 20, which is what? Z. So option A, no. B, no. C, yes, option C is the correct answer, Z. Question number 8. An element X with relative atomic mass 16.2 contains 2 isotopes, 16, 8 of X, so which means it has a mass number of 16 and atomic number of X, with relative abundance of 90%, and element X having a mass number of M, an atomic number of 8. You can see that the atomic number are actually the same thing, 8 and 8, so which means both of them are isotopes, okay? But they will have different what? Mass number. So with relative abundance of 10% for this. So the value of M is what? So we can work our way back, just adding up the relative abundance of each of the isotopes, adding them up together should give us the relative atomic mass to be 16.2. So let's move to the board now so we can see what we have. So the first one, we have 90% of the first isotope is 16 and then 8 for element X. So we have that here. We add it to the second one is what, 10%. Yeah, 10% of mass number M and then atomic number for the same element X. So all should be equal to the relative atomic mass of the element. Okay, so what do we have now? So our business here is just with the what? With the mass number, with the mass number that we have here. So we have this to be 90%. So we have 90% of 16 bracket plus 10% of M. Okay, of course, M is the unknown. That's what we want to find. Then the relative atomic mass we are given from the question to be 16.2. So 90% means 90 over 100 multiplied by 16 over 1. Then we have plus 10% is 10 over 100 multiplied by M. All equal to 16.2. Okay, so we have 0 cancels 0 here. We have, of course, this is 9 over 10. 9 over 10 is 0.9. Okay, so we have 0.9 times 16 here. Then we have plus. This is 0 cancels 0. This is 1 over 10 is 0.1 times M. Please, if you have a calculator, just punch it so that you'll be fast. Okay, you know we don't have a calculator here. So this will be equal to 16.2. So by the time you multiply this by this, 16 by 9, what do we have? That is 5, 4. Okay, that is 9 plus this, that is 1, 4. So we have 1, that's 14.4. So that gives us 14.4 here plus 0.1 M. So that will be equal to 16.2. So we can move this to this side so that we have 0.1 M left equal to 16.2 minus 14.4. So if we subtract 14.4 from this, that gives us, that will be 0.8. Yeah, so we have 5 minus this, it gives us 1. So that is 1.8. So divide both sides by 0.1, divide by 0.1. So M, of course, should be equal to, we move this once, we move this once. So that is 18 now, 18 over 1. So that is actually equal to 18. So which means that the mass of M, the mass number actually here is 18. So we can actually write it as the two isotopes are 16 and 8. And then the other one is what? 18 and what? 8 of X. Of course, you can guess what element it is. So let's move on to the board, to the screen to see what we have there. We have option A is 16, option B is 18, option C is 12, option D is 14. So the correct answer there for what we got on the board is 18. So the correct answer is option B. Question 9. Which of the following statements is correct about the average kinetic energy of the molecules of a gas? We know that there's something that triggers the average kinetic energy of the molecules of gases. It is temperature. If the temperature increases, the relative the kinetic energy definitely is going to increase. There's a relationship between them. They are both directly proportional. So as temperature is increased, okay, what happens? The molecules of the gases begin to collide with each other or with one another and with the walls of the container in which they are in, and then that will now increase the kinetic energy because the molecules begin to what? The speed increases, and then the relative average kinetic energy actually increases. So if you look at option A, says it increases with increase in pressure. No, even though they are gases, it doesn't increase because the relationship is actually between average. That is one of the postulates, okay, the assumptions of kinetic theory, the way gases actually behave. We looked at that when we're talking about gas laws, okay, the Boyle's law, the Charles laws, and so on, how gases actually behave in one of our video lessons. So you can click on the description the link in the description below. That will take you to the Myschool website, so you'll be able to access those video lessons we have in chemistry. So option B says it's increased at constant temperature. No, if the temperature is constant, then the kinetic energy will also be constant. It's not going to increase, okay? But option C says it increases with increase in temperature. Yes, as temperature increases, kinetic energy also increases. Option D, it increases with increase in volume. No. So the correct answer here is option C. It increases with increase in temperature. Do you know you can take our practice questions on our simulated JAMB CBT past questions? All you need to do is just click on the link in the description below that takes you to the Myschool website. There, you'll be able to download the Myschool mobile app for your Androids and the Myschool software on your laptops and computers. Please go ahead and start practicing. Now, let's move on to question number 10. The pollution from petroleum spillage in rivers and lakes can best be dispersed by pouring detergents, passing of ships through the area, pouring organic solvents, evaporation. If you evaporate, don't forget that this is what petroleum spillage on the water. Okay, that will not disperse the oil spillage. Okay, that is there, because water eventually gets drained up, and then we still have that. But still, you still have some. It can be used, but it is not the best. Okay, don't forget we are saying what that can best be dispersed. Okay, so we're talking about pouring organic solvent. Organic solvent depends on the solvent you are pouring. Okay, because the oil actually are specific to the solvent that can disperse them. Okay, so they are specific. So option C is not. Option B says passing of ships through the area. If a ship passes through the area where the water has been, what's it called, with petroleum spillage, it will just go after some time. It will the oil will accumulate back again. So that will not totally, disperse the oil spillage. Option A, pouring detergents. Yes, pouring detergents actually have what we call the hydrophilic and hydrophobic parts of their ends. Okay, we have the head, we have the end, the tail side. Okay, the hydrophilic means water, loving. Okay, which is lipophilic, hydrophilic or lipophobic. And then the other one is what? Hydrophobic. If it's hydrophobic, something is phobic, that means there's fear. Okay, there's no love, there's hating. Okay, so that part that is hydrophobic is water hating. The one that hates water loves oil. Okay, so what happens is that end of the detergent will now attach to the molecule of the oil that is on the water. Once it attaches there, it will be able to pull it off. Okay, so that is what we call the hydrophobic, or we call it lipophilic. Lipo means from lipid, from oil. Okay, lipophilic, hydrophobic. So pouring detergents definitely is going to help to disperse. It's the best way to disperse of the petroleum spillage on water. So option A is the correct answer. I hope you enjoyed this content. If yes, please don't forget to click on the like button, hit on the subscribe button, and finally tap the notification bell to keep you notified once we upload our next video. Question number 11. Deliquescent substances are used for what? Cooling, wetting, melting, drying. The question is, what are deliquescent substances? We have substances that are deliquescent, substances that are hygroscopic, substances that are efflorescent. Okay, so substances that are deliquescent actually tend to absorb moisture. Okay, they absorb moisture content once they are exposed to the atmosphere. Okay, for instance, your caustic soda is an example of that. That's your sodium hydroxide. Okay, it's deliquescent because once you expose it, the pellets just absorb water from the moisture, from the moisture from the atmosphere, and then it becomes what? Moist, and then it eventually turns into solution with time. Okay, it will not just be moist. If it is hygroscopic will become moistened, but it will not turn to solution. Okay, efflorescence loses water. Okay, once the moisture content, once they are exposed to the atmosphere. So we are talking about a substance that can absorb moisture from the atmosphere. So if it can absorb moisture from the atmosphere or from the substance, it means that whatever substance you have kept underneath it, it will remove water, and what removes water dries. Okay, so if it's removing, it is drying. So on that, it is not cooling, Option A is not correct. Wetting is not wetting because it's not, adding water. It is absorbed. It is taking out water. C is melting. No. Option D is drying. Of course, from what I just explained about the liquescent substances, they tend to remove. They dry out. Okay, the water, they absorb moisture from the substance that are put there. So option D is the correct answer. Drying. Question 12. Pure solvents are obtained by what? Distillation, we have condensation, we have extraction, we have evaporation. Okay, we have also discussed this one in one of our video lessons when we talked about separation techniques. Okay, so please subscribe so you can have a good understanding, okay, of this concept of separation of mixture, separation techniques of mixture. We know that pure solvents, of course, the purity of the substance will mean that it has all of the substances that is there. It's just purely, it does not have any foreign, substance or object that is present in it. It is just a pure form of what it is. So, if you want to have pure form or pure solvents, okay, that is obtained, which of this method do we use? Distillation. Distillation has to do with two processes. You boil, okay, you boil the substance, and then there is evaporation. As evaporation takes place or vaporization takes place, what happens? It condenses. So as it condenses, you have that. So in distillation alone, these two processes, condensation and evaporation, are involved in distillation. Okay, because distillation, you have the substance that is left after the substance, the solvent has been boiled. Okay, you apply it. Once it boils, as it's boiling, it begins to what? The vapor that is supposed to escape is trapped. Okay, it's trapped. Once it's trapped, what happens? And then it cools. As it's cooling down, it condenses. Okay, so once it condenses, you have a pure substance or pure solvent in that. So whatever impurity that is in that will be left down. So because what is evaporating is what is actually vaporizing, is what is actually collected, condensed, cooled, and collected in a substance. So this is correct. Option C, B, condensation alone will not make it. There has to be what? It that is applied first, okay, before it does that. So extraction does not only do that, evaporation will not only. So if I explain that both condensation and evaporation actually are involved in distillation. This method is used in breweries and where spirited drinks are are manufactured and produced. Distillation. So pure substance, pure solvents are actually obtained in that form. So the correct answer is option A, distillation. Question number 13. What is the decrease in volume of air when pyrogalol is shaken with 30 centimeter cube of air? Of course, when we talk of air, we talk of oxygen, because that is actually, the part of air that undergoes combustion or burn, that supports burning. Okay, when we talk about pyrogalol is an organic compound. Okay, it has C6H8O3. Okay, I think so. This is H8O3, but it is an organic substance. Okay, so if you want to find out the decrease in volume, I think it's a straightforward question. We're told that we have 30 degrees shaken with 30 centimeter cube of air. And then when we talk about air, we are talking about what? Oxygen. So the question is that what is the volume? What is the percentage volume of oxygen in air? Okay, when we talked about air in one of our video lessons, we talked about nitrogen having about 78%, okay, oxygen having about 21%, okay, and then other one we have argon, noble gases, and other impurities. So let's look at the board now so we can see how to go about that. So all we need to do now is to find the decrease in volume now, to find the decrease in volume. Decrease in volume of what? Of air. What percentage is actually moved? So we just have what? The percentage, okay, of air itself, which is oxygen, okay, multiplied by what? The volume of air. Volume of air itself. So that will be, we said it is 21% of oxygen that actually makes up the total air. So, and the volume of air that we are given here is just 30. So we have 21% is 21 over 100 multiplied by 30 over 1. So this cancels this. So we are left with 21 multiplied by 3. That should be 63 divided by 10. So if you divide this 63 by 10, this is 1 0. So 1 0, we move decimal point here. So we have 6.3. So in other words, we have 6.3 is going to be what we have there as the what? As the volume of air that is decreased from the what? Total value of air. Let's move to the screen and see what we have here. We have 15 cm cube, we have 6.30 cm cube, we have 0.63, we have 0.06. So the correct answer is option B, 6.30 cm cube. Question number 14. Environmental pollution is worsened by the release from automobile exhaust of, I think this one should be a bonus mark, from automobile exhaust pipe. It is only one. We have other gases that are there, but there's one that is actually poisonous, okay? That is carbon 2 oxide, or what we call carbon monoxide. The formula is CO, okay? Where do we get? That's what we get from the what? Automobile exhaust. We get it from generator. It's poisonous because when it gets into the blood system, it attacks the iron that is in the blood, and then it does not allow oxygen to be able to attach there. So once it gets that, that's why you hear that some people are going through, they on their journey and then all of a sudden they are dead, because that CO2 is very, very poisonous once it gets into the body. So we get that from automobile exhaust, from generator, and that. So option A says water vapor. No, that is not contributing. It's not, worsened. The environmental pollution is not worsened by water vapor. No. We have steam. No, of course, when there's boiling, you have your steam coming up. We have smoke. Smoke is coming from this, because that's where we have our what? Carbon monoxide, carbon 2 oxide, carbon, and so on and so forth. And then we have heavy metals. This is not. So the correct answer here is option C, smoke. Question number 15. The chemical used for coagulation in water purification is. Please, I want to plead with you, just subscribe. Link all of these things we have discussed in our video lessons. If you go through them, these questions will be so easy for you to tackle. So just click on the link in the description below that takes you to the Myschool website. There you'll be able to see all of this one under the water treatment, how you can make your water purified, all the process that is actually involved. The chemical used for coagulation in water purification is aluminium tetrasulfate 6, copper tetrasulfate 6, sodium tetrasulfate 6, calcium tetrasulfate 6. I'll pick it from here. Calcium tetrasulfate 6, sulfate 6 is actually, used in what we call tofu. Tofu is a kind of food, okay? They use it in compressing it from soy milk, soya beans milk, okay? That's why you have that. So this is used there for, so not in the soy milk, not in the coagulation in water treatment. For this one, sodium tetrasulfate 6, that is used as a filler, okay, in detergent that we use in washing our clothes and doing our dishes and our house chores, okay? So that's what this is used in. For copper tetrasulfate 6, this is usually used when they want to make a fungicide, herbicide, insecticides, for insects and then fungi to eliminate them, okay? Aluminium tetrasulfate 6, they all look alike. Tetrasulfate 6, you can see it present in all of them. So, but this is what differ, the element, metallic element. So, aluminium tetrasulfate 6, is actually the correct answer. The reason being that this is the IUPAC name, or the other name, the scientific name that the alum that we use in the house. Okay, you put a stone, or maybe you put just some alum, put it inside water that is dirty, that has a lot of dirt. What happens? All the dirt will do what? They will clog together, okay, and then they will sediment, they will move down. That is one of the first processes we employed in water treatment, okay. For it to coagulate, we have it. You have it when you go to the villages, they use it there, okay. When they get water from the streams, they will put alum inside the water so that all the dirt will form solids, okay, sediment, and then will clog together, and then the water will settle down. Then the water you have up there is actually clean. Then you can decant it, bend it so that you can get the pure water. So aluminium tetrasulfate 6, which is our alum, is the correct answer. It's the chemical that is used for coagulation in water purification. So option A is the correct answer. Question 16. Phosphorus is stored underwater to prevent it from what? Actually, phosphorus is a non-metal, actually, okay, that is highly reactive to air. If it is exposed to air, it will react with oxygen. Don't forget, we say oxygen, when we talk about air, in most cases in chemistry, we're talking about oxygen because that's the part that supports combustion, that supports burning, actually. Okay, so phosphorus, when it reacts, it is exposed, okay, to air, it reacts with oxygen, and once it does that, it can ignite, okay, and then it can catch fire. So because of that, to prevent that from happening, they will now store it under water, okay, so that of course it does not react with air, okay, and invariably catch fire or turn into that. So with that, you know the right answer here. It's not dehydrating, it is not becoming inert. Of course, this is opposite, because when you say it is inert, you are saying that it is unreactive. No, it is reactive, okay. It is not smelling. No, it's what catching fire. So it does not react with oxygen and catches fire. So the correct answer is option D. Now let's move on to question number 17. In which of the following reactions does reduction takes place? We have chemical equations here of reactions, okay. Usually it is oxidation, reduction, reaction, but you must know that oxidation is what? Loss in electron or loss of electron, okay, while reduction is what? Gain of electron. We use the acronym OIL-REG. Oil, oxidation is loss of electron. REG, reduction is gain of electron, okay. So in other words, another definition for oxidation is that what? We have an increase in oxidation number, okay, of a particular atom of an element of ion is actually what? Oxidation. But when there's a decrease in oxidation number, there is a what? Reduction taking place. So the question says, in which of the following reactions does reduction takes place? Reduction. So what we'll be looking out for here is there an increase? Because you can see the valences here, the oxidation state here. Where do we have increase? Decrease, because we are looking at the reduction. Decrease, that's what we are looking at, not increase. If there is moving from left to right, if there's an increase, that's oxidation. But moving from left to right, when there's a decrease, that is reduction. So let's start with option A. Ion 2 plus, Fe2 plus, okay, we lose an electron to become ion 3. This is plus 2 plus 3. So that is an increase in oxidation number from plus 2 to plus 3. So this is what? This is what? Oxidation. Option B. You have 2 negative here, then you have, of course, this is oxygen, this is 0 here, okay, negative 2, 0, from minus 2 to 0, is that an increase? Yes, that's an increase, from minus 2 to 0, because 0 is actually greater than minus 2, so minus 2 to 0, so that is an increase. So that increase in oxidation number, that is also what? Oxidation, right? Okay, so here, this is chromium gains, okay, we lose 2 electrons also to become what? To become 2 positive. So this is what? 0 here, that's the oxidation state of this, from 0 here to plus 2. 0 to plus 2. So that's also an increase in oxidation number. So that is what? Oxidation. So let's look at option D. This is, we have plus 1 here. Okay, if you want to multiply this 2 times plus 1, that's plus 2. But let's just make do with this. This is plus 1 here, okay, and then you have here, this is 0 here. So either you are multiplying these 2 by plus 1 to do the total number of this, so that's plus 2 to 0, or you just take it as plus 1 here and then to 0, plus 1 here and 0 here. So that is what? Actually a what? Reduction from 1 to 0, or from 2 times this, that's 2 to 0. So from 2 to 0 is a reduction. So this is reduction. So the question says, in which of the following reactions does reduction takes place? So it is glaring from what we just did now that where we have a reduction in the oxidation state of hydrogen here from positive value to what? To 0 here is a reduction point. So the correct answer is option D. Let's move on to question number 18. This is P reacting with Q to give us, well, you see this is a reversible reaction, so either way, okay, can go forward or backward. So P reacts with Q to give us 3 of R, then plus what? Plus S. We have this in gaseous state, solid state, and then gaseous state here. So if you have P reacting with Q, then to give us 3R and that, then we have delta H is what? Negative. That is very important. Delta H negative. So it means that change in enthalpy actually is negative. So when we have change in enthalpy being negative, it means that that's what? An endothermic reaction, because what happens? Heat is actually what? Giving off to the environment. Okay? Heat is giving off to the environment. So the question says, which of the following will increase the yield of R? The yield of R, here is R. What will increase this? Okay? If it were that delta H were positive, an increase in temperature would have produced more of this. Were it that delta H were equal to positive, okay, if it were endothermic reaction, an increase in temperature will cause the equilibrium position to shift to the right, favoring more of what? More of the production of this, which is our what? Le Chatelet's principle. That's what it states. Okay, so but since this is negative, so which means that increasing the temperature is not going to work. So which means option B is not the answer. So again, using a larger closed vessel, if you use a larger closed vessel, it still does not change anything, because volume, it means that what we are talking about, if you use a larger closed vessel, you'll be increasing the volume of the container, but that does not actually increase this, because increasing the volume of the capacity of the container does not increase the reactant, what is reacting together. Okay, if the number of what you have for the reactant remains the same, if it's not increased, this more of this will not be formed. So which means option A is also not the answer. Option C says removing some S. Okay, this. Okay, so which means as we begin to, this one continues to react, as we continue to increase this one, and then more of this are being produced, and you remove this, you will have more of this to be left. Okay, so let this reaction continues. As this is being formed, you keep removing this. As I'm removing this, you'll be having more of this left, because they are not going to share again what they have in terms of the space. So even though this is a gas, okay, and this is solid, so removing some S, some of this S, and then leaving this one is going to definitely help us. So this is correct. Let's look at option D, adding a positive catalyst. Of course, catalyst will only speed up the rate of chemical reaction, the rate at which the reaction reaches completion. So this is also not correct. So the correct answer here, what will give an increase to the yield of R is what? To add, to remove, some or this S that we have here. Then we'll have more of this one being produced. So the correct answer is option C, removing some S. Question number 19. A metal M displaces zinc from zinc chloride solution. This shows that now for any metal to be able to displace the other metal from the solution, it means that it has more power, it is more reactive, okay, than it. Okay, if it is less reactive, it does not have the power to go and displace it and then come in, okay, into that place. Just imagine a giant and then a dwarf who is displacing the other one from the other. So the one that is more powerful, the one that is more reactive, will be able to displace the other metal that is less reactive from the solution. So we have zinc in its habitat, because its habitat is what? Zinc chloride. We have zinc present in that place. So a metal is coming to displace it from there. So that means it must be more reactive than it. If you look at the electrochemical series, you can see that. The option A says M is more electronegative than zinc. No, not at all. It is not. If it is, then that means that you are saying that it is, in more cases, it could be a non-metal, okay? Or even if it is a metal, that means you are saying that it is less reactive than zinc. So if it is less reactive than zinc, it does not have the power to displace zinc from zinc chloride. Option B says zinc is above hydrogen in the series. Is that true? I don't think so. So it is not. It is not the reason why that element can be able to. In fact, the element that is even displacing M here that the M that is displacing it is actually not even hydrogen, because hydrogen is actually not a metal, because it says a metal M displaces that. So which means this is not also correct. Option C says M is more electropositive than zinc. If M is more electropositive than zinc, it means that M is more reactive than zinc. It means that M is more powerful. It means that M is more reactive. It means that M is stronger than zinc. So it has the power to go to the solution where zinc chloride is and then pull out zinc and then stay there, because it is more reactive. So M is more electropositive than zinc. Yes, because it is what? It is more reactive than it. Option D says electrons flow from zinc to M. Electron flow from zinc. We can't determine that yet because we don't even know what M is. Okay, so if it is higher than it. But what this actually means, a metal to be able to displace another metal, it means that it is more electropositive, it is more reactive than it. So for that, option C is the correct answer. Do you have any question bothering you at all? Please feel free to ask your question. How can you do that? All you need to do is just click on the link in the description below that takes you to the Myschool website. There you'll be able to ask your question, and then solutions will be provided within the shortest period of time. Now let's go to question number 20. Which of the following best explains the increase in the rate of a chemical reaction as the temperature rises? Underline the word best. So which means it's possible that all of the options we have actually can increase the rate of chemical reaction, but which one is the best? Option A says the bonds in the reacting molecules are more readily broken. Yes, the bonds in the reacting molecules definitely would have been broken for reactions to take place. Okay, but we are talking about what? The one that will increase the rate of a chemical reaction. But something actually makes it possible for the bond in the reacting molecules to be more readily broken. We are not told if that is involved or if it is not. So that cannot be. Option B says the molecular collisions become more violent. The molecular collisions become more violent. Yes, the molecular, but what makes it? Something is actually responsible for the molecular collisions, okay, to become more violent. We don't know about that. So on its own, the molecular collisions becoming more violent will not just increase the chemical reaction, the rate of chemical reaction. So that also is not. Let's look at option C. A lower proportion of the molecules has the necessary minimum energy to react. The amount of energy, minimum amount of energy that is needed by chemical reaction to occur is actually what we call activation energy. But does this actually have it? No. Option D says the collision frequency of the molecules increases. Yes. The collision frequency of the molecules increases. What makes them increase? Okay, how does this happen? It will, if the collision frequency increases, definitely the rate of chemical reaction will increase. Once the temperature increases, what happens? The molecules of the gases begin to collide with each other, and then the average kinetic energy increases. So once that happens, the collision frequency is increased. It increases because the way they begin to collide with each other, that's seen in the collision theory. Okay, the rate of collision increases. There must be collision between the molecules for any reaction to actually occur. That is what the collision theory states. So the collision frequency, once it increases, definitely more energy will be released, and then the rate of chemical reaction also will increase. So based on that, option D is the correct answer. The collision frequency of the molecules increases. Do you have better explanations, or ways to solve some of these questions that have already been solved? So please do well to share with us. You can do that by going to the comment section, and there you will indicate the question number and then the solution you wish to share. Question number 21. What current in amperes will deposit 2.7 grams of aluminium in 2 hours? In 2 hours. This is electrolysis. What current in amperes will deposit 2.7 grams of aluminium in 2. Don't forget that Faraday's law, first law, actually looks at the relationship between the mass of the substance and then the quantity of electricity that is passing through it. Okay, so that's the relationship. But before we do that, we need to write out the chemical reaction of what is happening here first. Aluminium is involved. Don't forget that aluminium, we have to lose 3 electrons. Okay, aluminium ion will lose 3 electrons to become what? Aluminium metal. Let's move to the board so you can see what happens there. So we have aluminium here. Okay, first ion, aluminium ion, we gain, okay, that's gaining 3 electrons. Okay, we gain 3 electrons, gains 3 electrons to become aluminium metal. Okay, that's a solid there. So which means that ordinarily it should have been 1 Faraday, 1 mole, 1 Faraday is equal to 96,500 coulomb. We're giving that. Okay, so but because we have 3 moles of 3 moles of electrons, now 3 electrons that is actually given up there, so that 3 is going to affect this. So we have 3 times 96,500 coulomb. Okay, will liberate the mass of aluminium is always given to be 27 gram. Okay, we're giving that. This is the mass, 27 gram mass of this. So 3 moles of this multiplied by the Faraday, which is 96,500, will liberate 27 gram. Now, what is the quantity of electricity that will liberate 2.7? We're given what current in amperes will deposit 2.7 gram. Now, why do we need this? We want to calculate what current, but there's no way we can get the current without getting what quantity of electricity first that will produce this, because the relationship is that what quantity of electricity is actually equal to current times what? Times time. Okay, so we need to get this quantity. Okay, this coulomb, quantity of electricity that will produce this 2.7. So once we get that, we're already given what the time is, so we can get our current, and then we'll be good. But don't forget that whatever unit in time is given, it must be in seconds. So if you are given in minutes, you have to convert to seconds. If you are given in hours, you have to convert to seconds as well. So first, let us deal with this first, this Q. To get this Q, so permit me to clean up this. So to get this Q now, what we have is, of course, you cross multiply this. You have 3 times 96,500, this to give 27. Let me write it out this way. And then X, we give what? 2.7 grams. So when you cross multiply, what happens? So this will multiply this, and this will multiply this. So in other words, X will be equal to 3 times 96,500, then times 2.7. Okay, of course this 27 should have been multiplied by this, so we are dividing by 27 now, so that we can have this, so that X now becomes equal to, so this is without a calculator here, if you multiply, if you move this one once, that means you add 1 0 to this, so that this can be 27, so that we can eventually have 3 times 96,500 times 27 over what? 270. So in other words, 27 cancels 27 here, we are left with, that's 1, so we are left with 10 here. So 0 cancels 0 here, that is that. So that will be 3 times 9650. That's what we have left here. So if you multiply this 9650, multiply that by 3, that is 15, that is 18, 19, 1, that is 27 plus 1, 28. So we have 28,950 coulomb of electricity is what is going to actually liberate 2.7. So if that liberates 2.7 at that point from here, it liberates it to that. So which means that quantity, don't forget, quantity is directly proportional to what? Or which is equal to what? IT. Okay. Now we know what our quantity is, but don't forget that we need to convert time, because time was given in 2 hours. So time in 2 hours, we have to convert to what? The standard unit, which is what? Seconds. So we multiply 2 multiply by 60, since 60 seconds, 60 minutes make 1 hour, then 60 seconds make 1 minute. So times another 60 here. So that gives us, that is 60, that's 3006 times this, that should be 7200 seconds. That's what we have. So that will be Q now is equal to IT. Q is actually, we got that to be 28,950 equals to I is unknown. That's what we want to find, times T is 7200. So that I, which is the correct, will be 28,950 divided by 7200. Of course, this cancels this, and then 720 goes in this. I think that should be okay. That should be 4, approximately 4.0. So approximately, definitely, we're going to have 4 here as our answer. So which is the current that will pass through this should be 4. You can use your calculator to punch this to check what you have at this point. So I, the current passing through, is approximately 4 amperes. So let's move on to the board now and see what we have. Okay, we have 32, option A. No, we have 8, we have 4, C, we have this. So the correct answer is option C, 4 ampere. Question 22. Ethanoic acid is option A, tribasic, unionizable, option C, monobasic, and option D is dibasic. We just want to look at the basicity of an acid. That is under acid, bases, and salts. Ethanoic acid, what is that? That is your acetic acid, okay? And that is, of course, is an organic acid, and it is gotten from vinegar, and of course, it will turn blue litmus to red because it's an acid. So what is the formula for ethanoic acid? CH3COOH. CH3COOH. Okay, whether it's called ethanoic acid or it's called acetic acid, is the same thing. Okay, CH3COOH. So basicity has to do with what? The number of replaceable hydrogen ion. How many moles of hydrogen ion can be replaced by a metal coming in to form a salt. Okay, to form a salt. Now, in the case of HCl, okay, 1 hydrogen can be replaced here. Then we have Cl2, Cl that. So 1 hydrogen is replaced. In the cases of H2SO4, okay, we have, because we have 2 hydrogen here that can be replaced. So this will be 2 hydrogen ion, and then we have SO4 2 minus. Okay, because we have this. So this one is monobasic, 1 hydrogen ion. This is dibasic, 2 hydrogen. But for this, if you do this, we have only one. We have CH3COO minus plus H plus. So only 1 hydrogen can be replaced here. Only this hydrogen. So because it's only 1 hydrogen that can be replaced here, it is monobasic. Monobasic. Only 1 hydrogen can be replaced by a metal to form a salt. For instance, sodium can come in from sodium hydroxide to form sodium, ethanoate. Okay, we can have that. So only 1. So that is monobasic. Let's look at the option. Option A is tribasic. No. Unionizable. No. Monobasic. C. Dibasic. Option is C. So the correct answer is option C. Now let's move on to question number 23. Carbon reacts with 2 moles of sulfur, okay, to have carbon sulfide, disulfide, because this is 2 of this, okay, having that. So we have carbon reacts with this to give this. Then we have delta H equals to positive 89 kilojoules per mole. So which means that delta H change in enthalpy is actually a positive value. So what does it mean? It means it is what? An endothermic reaction. And an endothermic reaction, what happens? It is absorbed into the system. So the question says the chemical equation above implies that what? What can we depict from this? Let's see option A. Each of carbon and sulfur has 89 kilojoules of energy. No. Because it is the whole reaction. For this reaction to take place, to produce this, 89 kilojoules per mole is what is required. So it is not each of them having 89. No, so that is wrong. Option B, both carbon and sulfur contribute 89 kilojoules of energy. No, both of them did not contribute it. What happens is that this one and this one actually reacted to produce this. So what is required to give this as the product is 89 kilojoules, but it is not that both of them actually contributed 89 kilojoules per mole, no kilojoules per mole at all. So that is not correct. Option C says 89 kilojoules of energy is released. If it is released, so we are saying that energy is given out, is given off. So energy being given off means that it is what? Exothermic reaction. Exothermic reaction. So which means a delta H must be negative. But from here, delta H is positive. So which means that this is not correct because 89 kilojoules per kilojoules of energy is not released. Okay? Because if it is released, it means it is exothermic. But this is what? Endothermic. Option D says 89 kilojoules of energy is absorbed. Yes. That is the amount of energy that is what? That is absorbed into the what? The system for that reaction to actually take place. Once this reaction takes place, okay, 89 kilojoules per mole of energy is actually what? Absorbs. Because this is what? Positive. And then for it to be absorbed, for energy to be absorbed, heat energy to be absorbed, it means that it is an endothermic. The delta H must be positive. So which is what? So the correct answer is option D. Question number 24. We have 2 moles of SO2 reacting with oxygen O2 to form SO3. Okay. And then the delta H is negative 189 kilojoules per mole. So what it means is that this is an exothermic reaction because this is a negative value. Okay. So the question says that the equilibrium constant for the reaction above is increased by what? How do we have this equilibrium constant? Because this system is actually at equilibrium. This is a reversible reaction, forward and backward. So this will continue to what? To continue to take place, produce. Once we have a negative amount of that, the heat that is involved is what? Minus 189 kilojoules per mole. So the equilibrium constant for the reaction above is increased by what? What will favor this? Is it to increase temperature or decrease the temperature? Is it to increase the pressure or pressure? Of course, for the pressure, it has nothing to do with this, even though it is gaseous, because we are talking about for this to remain at this. In the options we have says option A, decreasing the temperature of the system, increasing the pressure of the system. Yes, of course, pressure of course also affects what? The rate of the equilibrium constant. Okay, the addition of a catalyst to the system, increasing the surface area of the vessel. Increasing the surface area of the vessel does not affect it because we're not all of them, they are all in gaseous states. Okay, so this will not definitely increase the equilibrium constant. Option C says the addition of a catalyst to the system, that will only speed up the rate at which the reaction gets to completion, but it does not affect the equilibrium constant. So it is not. Option B says increase the pressure of the system. If you increase the pressure of the system, does it affect it? For pressure, what we consider usually are the gaseous substances. Number of moles of the reactants on the left hand side and the number of moles of reactants on the right hand side. Let's consider that. So we have 2 moles here of SO2. We have 1 mole here. So 2 plus 1, okay, we have 1 mole here. 2 plus 1 gives us 3 moles totally, okay, on the left hand side. And then on the right hand side, we have what? 2 moles of the right hand side. So the rule is that for a kind of reaction like this, for pressure to have effect on this, okay, then what happens? The side, whether left hand side or left hand side, the side that has the lesser number of moles will be favored by increase in pressure. So if you increase the pressure of this, you are saying that more of this will be formed, but it cannot go back to form this one, because if you take it the other way around, it's going to be this. So this is not going to increase the pressure of, it's not going to increase the equilibrium constant. Then let's look at option A, decreasing the temperature of the system. If we decrease the temperature of the system, does it affect the equilibrium constant? Yes, it does, because this is a negative value here for delta H, and this is what? An exothermic reaction. And in an exothermic reaction, if it were endothermic, in an endothermic reaction, an increase in temperature will favor the equilibrium constant to shift to the right, thereby favoring the what? More of the product to be formed, okay, and vice versa. But a decrease in the temperature of the system definitely is going to affect the other way around. So which means that decrease the temperature of the system, and then the equilibrium constant also for this reaction will increase. They are what? Inversely proportional, because this is what? A negative value. This is an exothermic reaction. So in an exothermic reaction, an increase in temperature will favor the backward reaction, okay? More of this will be formed, okay? But a decrease in temperature will what? Will favor this reaction. So more of this will be formed in an exothermic reaction. So for that, the correct answer is option A, decreasing the temperature of the system. That will keep the equilibrium constant. Option A is the correct answer. Question number 25. Copper metal, because that's solid, react with nitric acid, that's tetraisonitrate 5, okay? And then we have, of course, this is an acid with a metal. So once an acid reacts, a metal reacts with an acid, okay, we have copper nitrate. Of course, this is an exception. Normally, when an acid reacts with a metal, we should have a hydrogen ion being given off. But in this case now, the exception is with nitric acid. That law does not hold with nitric acid. So you have copper nitrate here reacting to have what? With water, and then we have NO. So in the equation above, copper is what? Copper is what? So we are considering copper here and then copper here, because that's our area of concentration. An electron acceptor. Is it accepting an electron? Let's see. Is it accepting an electron? Okay, that means for us to know that, we need to determine what the oxidation state of copper here, copper is here. Okay, but for it to have been here, it means that it is actually, you know, is it being oxidized? We have a base. Is it a base here? Is it an oxidizing agent? Is it a reducing agent? First, what are reducing agent? What are oxidizing agent? Oxidizing agents, they are usually the one that gain electron, okay? They gain electron and then they become negatively charged. Reducing agents, usually they will lose electron and become positively charged. That's why all metals are said to be reducing agents in most cases. Though there can be some reactions when it comes to redox reaction where some metals can still act as an oxidizing agent, okay? So in other words, what we are saying is that you can see copper here at this point now, it has oxidation state of 0, and at this point, if you calculate here, this should be minus 1 times 2, that is 2. Then we have it to that. So it is having an oxidation state of, because this is a radical NO3, okay, minus 1. So that should be minus 1 times 2. That's minus 2, crosses to that side, becomes plus 2. So it is from 0 here to positive 2 here, okay? So if it's moving from 0 to positive 2, what happens? 0 to positive, that's an increase in oxidation number. If it's an increase in oxidation number, it means that oxidation has taken place. So reducing agents will undergo oxidation, while oxidizing agents usually will undergo reduction. So in this case now, what has happened here is that there has been an increase in oxidation number of copper from what it is from 0 here, from here to this point. So there's an increase in oxidation number, that's an oxidation, so which means that it is what? A reducing agent or a reductant. So reducing agents usually we go through oxidizing agent, they become oxidized, okay? They will go to oxidation, they become oxidized. So reducing agent they become oxidized, while oxidizing agent becomes reduced. So in other words, there's an oxidation that has taken place here from 0 here to positive 2 to what we have here. So which means that option A is not correct. It's not an electron acceptor there. Instead, it's the one that is given out we have. It's not a base. It is not an oxidizing agent, but it is a reducing agent, because it eventually there's an increase in oxidation number, and oxidation reducing agents actually go through oxidation process. So in other words, the correct answer here is option D, a reducing agent. I hope you enjoyed this content. If yes, please don't forget to click on the like button, hit on the subscribe button, and finally tap the notification bell to keep you notified once we upload the next video.